All right, we're going to do a video on mutations. And so when there's a single error in your DNA, just one nucleotide is wrong, it causes a big problem. And so one letter wrong, one nucleotide wrong on DNA translates to one nucleotide wrong on RNA, which translates to a wrong protein and can just really destroy everything. In fact, it's what happened with sickle cell and how sickle cell ever came to be in the first place. And so there's just a one letter error in the DNA, and that translated to a one letter error in RNA, as well as a wrong amino acid in our protein. And so a normal red blood cell looks like this, but the sickle cell from just one nucleotide wrong causes the blood cell to look like this. Now it can't carry oxygen and it gets stuck when it's trying to traveling, and these people really have a hard time. So we're gonna look at different types of mutations and how to recognize them using our codon chart. Let me get some RNA. We'll start with an original strand of RNA. There's no reason that we have to start with DNA and transcribe it. I'm gonna try to write a little small just to make sure that we can fit enough examples in to show you all of them. So our original strand will be 5 prime A U G G C U C. That's not a C. Go ahead and make C G A U A G. Oof. All right, the first step we want to do is to go ahead and translate our RNA into amino acids. AUG is methionine. GCU, let's take a look. GCU, alanine. CGA, CGA, arginine. AAA, lysine, which is a K, and UAG, UAG is stop. Okay, so we have our original, we know what we're working with. Let's get some mutations out here. Mutation 1. 5 prime, let's keep our AUG the same. Let's do G. Okay, instead of trying to look on the RNA for the mistake, we actually want to translate it. Okay, so even if you can spot the mistake, I want you to translate it for part of your answer. We know the first one's M, we don't even have to look. GCU, that one's the same. AGA, this one clearly changed because before we had a C and now we have an A. So let's find it on our chart. AGA is arginine. AAA, and then stop. So we end up with the same amino acid called Mark, even though this letter is different, right? This nucleotide is different, but we can see that our first one, CGA, is here at arginine, but AGA is way down here, which also happens to be arginine. So we actually call this a silent mutation. It's silent because you can't even tell that it was mutated. It still spells Mark. So as far as you know, there's nothing wrong with it. So anytime you have the same protein as you did the first time, it's silent. Let's do another one. mutation 2. Okay, we are going to do all right, same thing. Let's go ahead and translate it. G is M. GUU. Let's check our chart. GUU is valine. Right? This one didn't change. This one didn't change. This one didn't change. So now we have a misspelled word, and this is called a missense mutation. Missense is misspelled. So anytime your protein spells something different than your original, it's a missense. Do another one. Mutation 3. Right, we'll go ahead and translate it. AUG, that's an M. GCU, the same one we had at the beginning, so that's an A. UGA, that's different. Let's take a look. UGA is stop. So we have to stop. We didn't get to complete the whole protein. It's not finished. It's called nonsense. This is nonsense. We didn't even get to do what we wanted to. Ma instead of mark. Okay, so anytime the stop codon comes early, so we're expecting it down here, then it is a nonsense. One last mutation. All right, let's translate this one. That stayed the same. GGC, well, that's a different. GGC is glycine. UCG, serine. AAA, we already know from before. AUA, isoleucine. And we can't even continue because we only have 1 at the end instead of 3. And so what happened here, our mutation happened right here, where we actually inserted another nucleotide by mistake, right? It happens. Sometimes our DNA just copies it twice. And so this caused the whole reading frame to shift over, right? We were supposed to be reading GCU, but it shifted to include that other one, right? We were supposed to be reading CGA, but it shifted because of this G. This one ended up looking the same just because we had a bunch of A's in a row. But again, we were looking for UAG and it shifted over to UAU. So this is called we're doing those in purple. Let me keep it the same color. Frame shift, because it shifted the frame, but also a nonsense because we have different letters, right? We have a misspelled word. So it's a frame shift missense. It's both, and you have to name both. You'll always know it's a frame shift if when you break out the codons in 3s, you have an extra or one not enough. So it could come from an insertion or a deletion, right? So again, always translate it first. If your translation is the same as your original, it's silent. If it spells a different word, it's missense. If it stops early, it's nonsense. And if there's an insertion or a deletion that moves the whole frame, the reading frame, then it's a frame shift plus one of these three. Most of the times it'll be missense or nonsense. It's really hard to get a frame shift silent, but you have to include both frame shift and which of these first three. Okay, so that's how you'll do translation on your genetics assignment and on the test.